This video will be over functions. First, we need to go over some definitions. First definition we need to go over is what we call a relation. A relation is just a set of ordered pairs. And the second definition we need to go over is a function. A function is a relation where no x value repeats. Meaning, if you have a set of ordered pairs, all the first numbers of the ordered pairs will be different. We're about to go over an example of this. Alright, decide whether each relation defines a function. For relation f, the first one, you notice the first digits, the first numbers, the x values are 1, -2, and 3. Since none of the x values are the same, this would be a function. For function g, or not function g, relation g, if you look at the x values, the x value of 1 repeats 3 times, so relation g is not a function. And for relation h, the -2 repeats, so relation g is not a function. Alright, before we move on, let's go over different ways we can illustrate relations. The first way which we went over is just listing out the ordered pairs. Another way we can illustrate a relation is by what we call a mapping. For instance, let's take relation f from the previous example. Alright, so if we were to draw a mapping, it would look something like this. See how we have the x values in the oval on the left? The 1, -2, and 3, +3. And then we have the y values on the right, 2, 4, and 4. Since 4 repeats as a y value, we only have to write that once in the oval with the y values. So we start with the x value of 1, and we draw a mapping from 1 to its corresponding y value, which is 2. Likewise, for the x value of -2, it maps to +4, so we draw an arrow from -2 to +4. Likewise, for the x value of +3, its corresponding y value is +4, so we draw an arrow from +3 to +4. Alright, now that we've covered a different way to write a relation, let's go ahead and move on to the concept of domain and range. Now for domain and range, remember domain is the set of all x values. And range is the set of all y values. And in case you can't hear in the background, that's my 4-year-old daughter doing color commentary. Now for this example, it says give the domain and range of each relation. Tell whether the relation defines a function. So for part A, the domain would be the set of numbers. The first number should be 3, 4, 4, and 6. So you do a squiggly bracket, 3, 4, and 6. You only have to write the 4 once. And the range, it'd be -1, 2, 5, and 8. So squiggly brackets, -1, 2, 5, and 8. And this, since the x value of 4 repeats, this would, part A would not be a function. So let me erase this and we'll move on to part B. For part B, the domain, would be the set of numbers -3, 4, 6, and 7. Because if you notice, they're all mapping, the blue circle is mapping to the red circle. So the blue circle would be the domain, which means the numbers in the red circle would be the range. So it would be the set of numbers 100, 200, 300. And since none of the x values repeat, part B would be a function. For part C, the domain, set of all x values, I have to just look under the column for x, so that'd be -5, 0, and +5. And the range, since the only number in the range is +2, so you write the 2 once. And since none of the x values repeat, part C would be a function. So, for example 3, it says find the domain and range of each relation. Part A, the domain. Notice the first numbers are all in blue, so write the blue numbers for the domain. So it'd be -1, 0, 1, and 4. And the range, looks like it's just all the y values, the red numbers. So it'd be -3, -1, 1, and 2. And I think that's all it asks for. So now let's move on to part B. Part B, it has the domain outlined in, looks like that greenish teal color. Looks like it's all the numbers from -4 to +4. So you can say that x is greater than or equal to -4, or x is less than or equal to +4. However, just to write it as a single inequality, we write the set of all x values such that we do a vertical line, then -4. Now, if you look at the inequality with -4, it's pointing towards the -4. So you can do -4 is less than or equal to x. Because as long as it's pointing towards the same number, since it's still pointing towards -4, it means the same thing. So -4 is less than x. And with the +4, it's open towards the +4. So it's less than or equal to +4. Remember, with the two inequalities, the smaller number always goes on the left, the bigger number always goes on the right. So, on any sort of homework or exam, you could write your domain like this. Or, since it's less than or equal to, you could write it as brackets. From -4, since it does touch the -4, to +4. Since it also touches +4, you would do brackets around the +4. Either of those would work for domain. Now for the range. It's the same concept, it's just that now you're dealing with the y's. So it'd be -6. Pretty much the signs will be pointing the same way with domain and range. So it'd be -6 is less than or equal to y. And y is less than or equal to +6. And we get that because if you see here on the graph, the lowest value is -6. And we want all the y values that are greater than or equal to -6. Since it's still pointing towards the -6, that's where we get the -6 is less than or equal to y. And we want all the y values that are less than or equal to +6. That's where we get this part right here, the less than or equal to +6. That's how we can write it like that. Or if you want to do it like brackets, this is another way that I'd want you to do it on your test. Or that you could write it on your test. Let's put it at that -6, from -6 to +6 with brackets. Now for part C, the domain. You notice it keeps going towards the left, or towards the right and towards the left. Since it keeps going in either direction, the domain would be all real numbers, which we denote with the weird R symbol. Likewise for the range. The graph keeps going on forever and ever in both the upward or downward direction, so the range would again be the set of all real numbers. Now, the way you can tell if a relation is a function based on the graph is by what we call the vertical line test. Basically, if you draw a vertical line through a graph and it only intersects one time, no matter where you draw the vertical line, then it is a function. But if you can draw a vertical line through the graph and it intersects more than once at any point, or in any location on the graph, then it's not a function. And for this example, it says use the vertical line test to determine whether each relation graphed in example 3 is a function. And in case you've forgotten or didn't write it down, here are the graphs from example 3. Alright, here are the 4 graphs, so like in part A, you notice let me enlarge this. No, you can draw a vertical line through each of the 4 points on the graph, and it never crosses another point on the graph. So part A would be a function by the vertical line test. Part B, you can tell this fails the vertical line test at infinitely many points, so this would be not a function. For part C, this does pass the vertical line test and infinitely at every point on the graph, so this would be a function. And for part D, this also passes the vertical line test at every point on the graph, so part D also would be a function. Now, skipping part D, because I think you get the idea, we're going to move on to another example. Alright, so for this example, it says decide whether each relation is a function, and then determine the domain and range. Alright, for part A. Alright, x plus 4. Notice we get each x value by simply adding 4. So for every different x value, since you're strictly just adding 4, you'd get a different y value. Like if you plugged in 1, you'd get 5, plug in 2, you get 6, plug in 3, you get 7. So, A would be a function. And now, since we can plug any value of x in there, if we plug in any value, since we can plug in any value of x, the domain would be all real numbers. Or to use the set notation that we used earlier, you know how we did from -4 to +4? That's like with the brackets, that's what we call set notation. To write all real numbers as set notation, it would be from -infinity to +infinity. We use the parentheses because we can never touch infinity. Likewise, since the y values are just 4 more than the x values because we're adding 4, the range would also be all real numbers, or from negative infinity to positive infinity. Alright, so for part B, you notice since for part B, we're always taking the non-negative square root of a number, so for whatever value we plug in for x, after we simplify it, we'll always take the positive square root. So each x value, no two x values will give you the same y value. Since each x value will give you a different y value, that means no two x values can repeat. So this would be a function. Like if you plug in 1, you'd have the square root of 1, which is positive 1. Plug in 5, you'd get 2 times 5 is 10, minus 1 is 9. So it'd give you 3 as a y value. So that's my point, that all the x values repeat. Now, the domain. We cannot have a negative number underneath the radical, so this 2x minus 1, after you simplify it, must be greater than or equal to 0. Now we're going to solve for x, and that will tell us our domain. Since we're subtracting 1, we would add 1, so you have 2x. After those cancel out, it's greater than or equal to 1. Or if you divide by 2, or after you divide by 2, x is greater than or equal to 1/2. So our domain is all the x values greater than or equal to 1/2, or from 1/2 to infinity. Since you can never touch infinity, there would be parentheses around the infinity. But since it can be equal to 1/2, the domain would have a bracket around the 1/2. And the range for part B. Since it's a square root, the y values have to be non-negative, which means it'd be all the y values greater than or equal to 0, or from 0 to infinity. Again, it'd be parentheses around the infinity, but since it can be equal to 0, we'd have a bracket around the 0. So for part C, y squared is equal to x. Now, if you notice, the same x, if you notice we have both the y values 4 and negative 4, we're going to figure out the ordered pairs for these. You notice if you plug either of these y values into here, you'd get positive 16 for the x value. That means the x values, there are a lot of x values that will repeat, so this would be not a function. And the domain, if you notice, we're squaring the y's to get the x, so the domain would just be any non-negative number, meaning x must be greater than or equal to 0, or from 0 to infinity. Since it can be equal to 0, we have brackets around the 0. And the range. Since we can plug any number into the y's, the range would be just any real number, so it'd be from negative infinity to positive infinity, or the set of all real numbers. Now in this next example, we're going to learn how to use function notation. Alright, so for this example, we're going to learn what this function notation means. So, for part A, we're going, when it says f of 2, that means everywhere there's an x in f, you plug in 2. So it'd be negative 2 squared instead of negative x squared plus 5. To have 5 times x would be 5 times 2 minus 3. So negative 2 squared, this would be negative 4 plus 5 times 2 means it'd be plus 10 minus 3. So negative 4 plus 10 would be positive 6 minus 3 would be positive 3. So, now we're going to move on to part B. F of Q. That means everywhere there's an x in f, you plug in 2, or q. So instead of negative x squared, it'd be negative q squared. Instead of plus 5 times x, it'd be 5 times q minus 3. And for part C, you have g of a plus 1. So that means you go to, for the x in g, you plug in a plus 1. So instead of 2 times x, it'd be 2 times a plus 1 plus 3. So now, we distribute 2 times a, which is 2a, 2 times positive 1 would be plus 2, and then plus 3. So that would be 2a plus 5. Alright, for this example, which also goes over using function notation, it says find f of 3. So for part A, it tells you that f of x is equal to 3 times x minus 7. So for part A, since you have f of 3, instead of 3 times x, it'd be 3 times 3 minus 7. So 3 times 3 is 9, minus 7 means that a would be 2. For part B, when x is 3, y was 1, so f of 3 for part B would be 1. For part C, you notice when x is 3, 3 maps to 5, so part 3, f of 3 would be equal to 5. And for part D, I'm going to zoom in on that. To find f of 3, you go to where x is 3, and you find where it intersects with the graph. And the corresponding y value would be positive 4. So for part D, f of 3 is equal to 4. Now we're going to go over how to find an expression for f of x. So basically, in order to find an expression for f of x, you first solve it for y, and then you replace y with f of x. And here's an example to illustrate finding an expression for f of x. So for this example, it says, assume that y is a function f of x. Rewrite each equation using function notation, then find f of negative 2 and f of a. So for part A, since it's already solved for y, you just have to replace y with f of x. So f of x equals x squared plus 1. Now f of negative 2 equals negative 2 squared plus 1. Negative 2 squared would be positive 4, plus 1 would be 5. And then f of a just means everywhere there's an x, you replace it with a, so it would be a squared plus 1. These three parts would be your answer because it asks for all three of them. And for part B, we need to solve it for y. So let's go ahead and get rid of the x, subtract x from both sides. So you end up with negative 4y equals 5 minus x. Now, divide by negative 4, and y is equal to 5 minus x over 4. Or you could to rewrite that, that'd be f of x equals 5 minus x over 4. F of negative 2 now would be 5 minus negative 2 over 4. 5 minus negative 2 would be positive 7 over 4. And f of a would be just 5 minus, instead of x, it'd be 5 minus a over 4. So those three would be your answer for this problem. Now, I would like to illustrate something about part B. 5 minus x over 4. Now, normally what we would do is we'd put the x first. So it'd be negative x. Since it's positive 5, it'd be plus 5 over 4. Now, since they have the same denominator, you can put them in separate fractions, so negative x over 4 plus 5 over 4. Or since there's no number in front of the x, just a minus sign, that'd be negative 1/4 x plus 5/4. So you could have simplified it like this too. Just figured I'd tell you that. It's another way to work it. Now, another thing we need to talk about is increasing, decreasing, and constant functions. So basically, a function is increasing if, as the x values increase, that's what the x1 is less than x2 means. As the x values increase, the y values are also increasing. It's decreasing if, as the x values increase, the y values are decreasing, meaning the graph is getting lower in the y direction. And it's constant if, for every x value, the y values are the same. Let's do an example over increasing, decreasing, and constant. So for this example, it says that figure 29 shows the graph of a function. Determine the largest intervals over which the function is increasing, decreasing, or constant. Alright. If you notice, for all the x values to the left of 1, as you go in this direction, as you go right towards negative 1, meaning as the x values are increasing, the y values are decreasing. So that means it's decreasing for all the values less than positive 1. So meaning from negative infinity to positive 1. And you see how there's an open circle around positive 1? That means it cannot be equal to positive 1. So there'd be parentheses around the positive 1. Remember, if you were to write this as an inequality, you just say for all the y values less than positive 1. Now, if you notice, as x increases from 1 to, looks like 3, as the x values are increasing from 1 to 3, the y values are also increasing. So that means it's increasing. Now for that piece of the graph, it's closed in at positive 1, so there would be a bracket around the positive 1, so it would be from 1 to 3. And there would also be a bracket around the 3, because if you notice, there's no open circle. If you notice, from positive 3 onward, as x values increase, the y values are staying the same. So it's constant from 3 to infinity. Since you can never touch infinity, it'd be parentheses around the infinity. But since it can be equal to 3, there'd be brackets around the 3.